students, in today's session we are going to study about the analysis of coal. We have already studied that coal can be analyzed in two ways. The first way is proximate analysis and the second way is ultimate analysis. We have already seen what proximate analysis is. In that we try and kind of figure out the percentage of volatile matter, the percentage of moisture, the percentage of ash, and many more things. And ultimate analysis, we are going to take this particular analysis to a further next level and actually try and figure out what are the different elements, what is the proportion of different elements, and how useful a carbon can be as a fuel with the help of this analysis. So let's dive into ultimate analysis. Ultimate analysis. It means finding out the weight percentage of carbon, hydrogen, nitrogen, oxygen, and sulfur of the pure coal free from moisture and inorganic constituents. What do we mean by that? You always perform ultimate analysis after the proximate analysis is done. You cannot take coal directly out of the mine and start off with ultimate analysis. Ultimate analysis is the step which comes after the proximate analysis. Now why so? Because when I perform proximate analysis, I make sure that I am removing moisture, I am removing ash, I am removing carbon content, I am removing different things from that coal, making the coal as pure as possible. That means all different inorganic constituents and moisture is being removed. After that, we see in that particular carbon what are the different elements. That means that particular piece of coal must be having very different kinds of elements. In ultimate analysis, the elements are carbon, hydrogen, nitrogen, oxygen, and sulfur. So all these 5 elements are present in coal. The main element which is needed is carbon. Carbon is the element which will actually lead us to the ignition and the combustion process, eventually giving out fuel. But before that, it is important to understand what are other different elements present in it and how will they eventually affect the calorific value or the capability of the coal to produce heat and light. In short, giving us different kind of energy. This analysis gives us the elementary constituents of coal. That means this analysis is giving us the basic constituents of coal. It is useful to the designer of coal burning equipments and auxiliaries. Now, the percentage of different elements of coal will actually help us in finding out what that particular kind of coal is capable of. That means if I have a coal with a very large amount of carbon, with higher percentage of carbon, that particularly means that that carbon is of good quality. And if I have good quality carbon, then I can use it for industrial purposes. But if I have mined out a carbon coal which is not of that good quality, then I can use it for domestic purpose as well. Let us see the ultimate analysis. Determination of carbon and hydrogen in coal. The first thing we do is we determine the carbon and we determine the hydrogen. Now why do we do that? Because most of the fuels are made up of hydrocarbons, where hydro stands for hydrogen and carbon stands for carbon. So when I'm talking about hydrocarbons, I have different kinds of hydrogens and carbons present in it, and thus it is important to find the percentage of these two basic elements, the element of carbon and the element of hydrogen. A known amount of coal is burnt. Generally, it is a unit gram of coal. That means 1 gram of coal. But even if we want to make an analysis for a larger set, we can take a higher amount of it as well. The most important part of that particular coal should be that proximate analysis is already done. The coal is free of moisture, volatile matter, and different inorganic content, and the amount of it is known to us. So known amount of coal is burnt in presence of oxygen, thereby converting carbon and hydrogen into. Now if I have coal which is burning in presence of oxygen, the process of combustion will take place. What is exactly the process of combustion? When carbon combines with oxygen, to give heat and light. That particular process is known as process of combustion. Of course, light is a very small amount of energy. Generally, during the process of combustion, what comes out is the amount of heat, and huge amounts of heat come out. So now, when coal is burnt in presence of air, basically in presence of oxygen, because air contains oxygen, oxygen will go and combine with the carbon which is present in the coal, and it gives us C plus O2, CO2. Carbon plus oxygen giving us carbon dioxide. And when hydrogen comes and combines with oxygen, we get H2 plus half O2 giving us H2O respectively. That means when coal is burnt, it will give us two major products. The first product is carbon dioxide and the second product is steam. The products of combustion, carbon dioxide and water, are made to pass over wade tubes of anhydrous CaCl2 and KOH, which absorbs H2O and CO2 respectively. That means once this entire combustion process takes place, once carbon dioxide and water are evolved, they are passed through CaCl2 and KOH, which will absorb the H2O and CO2 respectively. The increase in the weight of CaCl2 tube represents the weight of water form, while the increase in the weight of KOH tube represents the weight of CO2 form. Why so? Because CaCl2 is the tube which is actually going to soak in or absorb in all the steam which is being formed, and KOH tube is the one which is going to soak in or absorb in all the carbon dioxide formed. Percentage of carbon and hydrogen in coal can be calculated as follows. Now let us see the percentage of carbon dioxide and water. Let X be the weight of the coal sample taken. So we know that the coal sample is a known weight, but let it be X as of now. Let Y be the increase in the weight of KOH, and let Z be the increase in the weight of CaCl2. So over here we have three variables. The three variables are X, Y and Z. X is the weight of the coal sample taken. Y is the increase in the weight of KOH. Z is the increase in the weight of CaCl2. Now we know that carbon itself and oxygen 12, oxygen is 32. Why 32? Because oxygen is 16. O stands for 16. So it will become 16 into 2 because we have O2. So 12 plus 32 eventually gives us 44. 44 grams of CO2 contains 12 grams of carbon. So over here we'll do cross multiplication. If 44 grams of CO2 is containing 12 grams of carbon, then 1 gram of CO2 will contain how much? So it will be 1 into 12 upon 44. 1 into 12 is 12 itself. So it will be 12 by 44 grams of carbon. Y grams of CO2 contain 12 by 44 into Y grams of carbon. So what will be the percentage of carbon in coal? 12 by 44 into Y by X into 100. Now why have I done into 100? Because we are finding the percentage of it. So always the percentage is into 100. Similarly, we have done this for hydrogen. We know that the atomic number of hydrogen is 1. But over here we are talking about H2. So H2 is nothing but 1 into 2. So it comes down to 2 half O2. So if you cancel off half and 2, we'll get single oxygen, which is nothing but 16. And then we have H2O, which is 16 plus 2, which is 18. So 18 grams of water contain 2 grams of hydrogen. So if 18 grams of water is containing 2 grams of hydrogen, then 1 gram of water will contain how much? Again over here we will do cross multiplication. It will be 1 into 2 divided by 18, which is 2 by 18. We can also reduce it to 1 by 9 because 2 ones are 2, 2 nines are 18. But as of now we have just kept it 2 by 18. So Z grams of water contains 2 by 18 into Z. So percentage of hydrogen will be 2 by 18 into Z by X into 100. Over here also we have done into 100 because we really want to find out the percentage of hydrogen. Now we have already defined and determined the percentage of carbon. We have already determined the percentage of hydrogen. We did this with the three variable process X, Y and Z, and we had passed on carbon dioxide and water in the form of steam onto CaCl2 and KOH tubes. Now we have got carbon, we have got hydrogen. The next thing we are trying to find out is nitrogen. Nitrogen estimation is done by Geldar's method. A known amount of powdered coal is heated in concentrated H2SO4 and K2SO4 in long naked flask. The long naked flask is also known as Geldar's flask, thereby converting nitrogen of coal to ammonium sulfate. So now what are we doing? We are taking that amount of coal and we are heating it in presence of two things, H2SO4 and K2SO4. So if I have H2SO4 and K2SO4 present in it, what do we do next? We heat it in the presence of long flasks known as Geldar's flask, and then we convert that nitrogen into ammonium sulfate. When the clear solution is obtained, that is the whole nitrogen is converted into ammonium sulfate, it is heated with 50% NaOH solution. Over here, if you see, NH4 twice SO4 is nothing but my ammonium sulfate, and it is heated with 2 NaOH. So what will happen over here? The Na will go and take place of NH4 twice. So you get Na2SO4 plus 2 NH3. NH3 is nothing but ammonia. The ammonia thus formed is distilled over and absorbed in a known quantity of standard 0.1 normal HCl solution. So over here what is happening? We are distilling off the ammonia in a proper HCl solution, and the HCl solution is nothing but of 0.1 normal. The normality is 0.1. The volume of the unused 0.1 normal HCl is then determined by titrating against standard NaOH solution. Thus the entire distillation and the titration process takes place to give us the results. Thus the amount of acid neutralized by liberated ammonia from coal is determined. Over here, how is it determined? If you see, you have volume of 0.1 normal HCl as A milliliters and volume of unused HCl is B milliliters. So acid neutralized by ammonia will be how much? A minus B milliliters. We know 1000 ml of 1 normal HCl is 1 mole of HCl, which is equal to 1 mole of NH3, which is equals to 14 grams of N2. So now if I want to find A minus B milliliters of 0.1 normal HCl, what will I do? I will have 14 into A minus B into 0.1 upon 1000 into 1 normal, and that will be my grams of N2 or nitrogen. So we are doing this for X grams of sample of coal, so it will be 14 into A minus B into 0.1 upon 1000 into 1 grams N2 percentage. Now how do we find the percentage? We take the entire formula and we multiply it by 100. So 14 into volume of acid consumed into normality upon 1000 into weight of coal sample, which is equal to 1.4. Now how did I get 1.4? Because we cancelled off the 1000 with the 100 and then only 10 was remaining. 1 by 10 is nothing but point, so we can have it as 1.4 into volume of acid consumed into normality upon weight of the coal sample. Now we have determination of sulfur in coal. So we have determined carbon, we have determined hydrogen. After that we determine nitrogen. Now we will be determining the amount of sulfur. A known amount of coal is burnt completely into a bomb calorimeter in presence of oxygen. So what have we done over here? We have taken a known amount of coal. We have taken the instrument as bomb calorimeter, and then we have burnt the coal in presence of oxygen. Ash thus obtained contains sulfur of coal as sulfate. That means that once the entire coal is burnt and cooled down, we will collect the ash which is present over there. That particular ash contains the sulfur which is present in the coal in the form of sulfate, which is extracted with dilute HCl. So that particular sulfate is extracted with the help of dilute HCl. The acid extract is then treated with BaCl2 solution to precipitate sulfate as BaSO4. So now that particular sulfate is treated with BaCl2, and when BaCl2 reacts with that sulfate which is present in the coal, it comes out as BaSO4. The precipitate is filtered, washed, dried and weighed, from which the sulfur in the coal can be computed as follows. Let us see how can we calculate sulfur. So if I have X, which is the weight of coal sample taken, then M is the weight of BaSO4 precipitate. All of us know that S plus 2O2 is giving us BaSO4. So over here we get 233 grams of BaSO4, 233 because barium plus sulfate plus 4 times of oxygen. So 233 grams of BaSO4 contain 32 grams of sulfur. Then 1 gram will contain how much? Again over here what will we do? Cross multiplication. 1 into 32 upon 233. 1 into 32 is nothing but 32 upon 233. So we get 32 upon 233. So m grams of BaSO4 will contain 32 upon 233 m grams of sulfur. Percentage will be how much? Now percentage is in the entire coal, in the entire amount of coal. So it is 32 upon 233 into m upon x into 100. Now why have we done into 100? Because we are finding out the percentage of sulfur, and whenever we find out the percentage we do into 100. Over here now we have learned to find out the percentage of carbon, the percentage of hydrogen, the percentage of nitrogen and the percentage of sulfur. So this is how we find out different things when it comes to ultimate analysis of coal. Now we'll just see the significance or the importance of ultimate analysis of coal. The first is finding the carbon and the hydrogen. It is very important for us to know the amount of carbon, the percentage of carbon, the value content of carbon inside a coal, because the only element which will work during the combustion process, the only element which will give us energy and fuel is carbon. Everything else is nothing but garbage. Everything else is not useful. Only carbon is useful. Higher the percentage of carbon and hydrogen, better the quality of coal, and higher is its calorific value. Now, what is calorific value? Calorific value is the value of a carbon which helps us to understand the amount of carbon or the amount of hydrogen or the amount of heat it will produce. The percentage of carbon is helpful in classification of coal. The higher the percentage of carbon in coal reduces the size of the combustion chamber. Even if I have a very small combustion chamber with very good quality of coal, it will provide me with really good quality of heat. Second is nitrogen. Nitrogen does not have any calorific value and its presence in coal is undesirable. Nitrogen itself does not have any particular value when it comes to the calorific value, and thus its presence is not desirable. Good quality coal should have very little nitrogen content. As little the nitrogen content, better the quality of coal. Third is sulfur. Though sulfur increases the calorific value, its presence in coal is undesirable. Overall, if you see in different fuels, sulfur is good. But when it comes to coal, it is not desirable. The combustion products of sulfur, that is SO2 and SO3, are harmful and have corrosion effects on the equipments. It is very important for us to safeguard the equipments as well. The equipments which we use for the sulfur or which we use for actual coal is very important. And if some gases are corroding the equipments are very expensive. The coal containing sulfur is not suitable for the preparation of metallurgical coal as it affects the properties of the metal. Thus, sulfur is undesirable. Finally, we have oxygen. Lower the percentage of oxygen, higher will be the calorific value. Same as nitrogen. Lower the percentage of oxygen, higher will be its calorific value. As the oxygen content increases, its moisture holding capacity also increases and the calorific value of the fuel is required. With this, we finish with the ultimate analysis of coal. Over here, we have seen the exact process and the calculations of ultimate analysis of coal, as well as we have seen the importance of it. Thank you.